Friends, every banknote in circulation tells a story that most people never think to ask about. It passes from hand to hand, moves through markets and machines, travels across cities and borders, and yet the extraordinary complexity behind its creation remains almost entirely invisible to the people who use it every day. The currency of Israel is no exception. Each note in the Israeli series represents the end point of a production chain so long, so precise, and so technically demanding that it spans continents, centuries of accumulated expertise, and some of the most sophisticated manufacturing processes that human industry has ever developed. To understand what a banknote truly is, you must follow it from its very beginning. And that beginning is not a printing press, it is a field. Cotton has been the foundation of banknote paper for centuries, and the reason is rooted in the fundamental biology of the plant itself. Each cotton fibre is a single hollow plant cell of extraordinary tensile strength and natural flexibility. Unlike wood pulp, which forms ordinary paper, cotton fibre bonds to itself through a process called hydrogen bonding, creating a sheet material that can survive thousands of folds, exposure to moisture, and the relentless mechanical stress of daily handling without degrading. Central banks worldwide have trusted cotton as the substrate of their currency for precisely this reason. At peak harvest time, mechanical cotton pickers move through vast fields of white bolls, stripping the dense white fibre from the plants row by row at scale. The harvested cotton then travels to gin facilities, where rotating saws and brushes work at high speed to separate the valuable white lint from seeds, stems, leaf matter, and all foreign material. What emerges from the gin is clean, pure cotton fibre, hydraulically compressed into standardised bales, certified by batch, and prepared for shipment to the specialised security paper mills that will transform raw agriculture into one of the most technically engineered materials on Earth. At the security paper mill, every bale arrives under strict chain of custody documentation. Technicians sample every batch, pulling fibre strands and inspecting them against demanding specifications for length, cleanliness, and tensile consistency. Only certified fibre advances. The approved cotton enters a sequence of mechanical opening and cleaning machines that progressively refine the fibre until it is fed into the Hollander beater, the most critical machine in the entire substrate preparation process. The Hollander beater does not cut fibres. Its heavy rotating bar abrades the cotton continuously against a fixed bed plate, microscopically fraying and opening the cell walls of each fibre strand, dramatically increasing the bonding surface area available when the paper sheet ultimately forms. A technician monitors the beating level using a standardised freeness test, confirming that the fibre suspension has reached the exact specification required for security paper-grade production before the process advances. Into this beaten cotton suspension, the mill introduces the elements that will make these sheets categorically different from any ordinary paper. UV reactive security fibres, fine coloured threads cut to precise lengths, are blended directly into the furnish, distributing randomly throughout the suspension, so that every square centimetre of finished paper will carry these threads embedded within its structure, glowing brilliantly under. Ultraviolet illumination, strength, enhancing chemical additives are introduced to maximise the note's resistance to folding, soiling, and handling stress across years of heavy circulation. Optical brightening agents are measured and added to ensure the paper's surface renders the printed design with maximum colour fidelity. The complete furnish is mixed under continuous agitation until perfectly uniform, then filtered through fine industrial screens and diluted to the exact concentration the paper machine requires. The paper machine receives this furnish at the headbox, distributing it with absolute uniformity across the full width of the forming wire. As the dilute suspension lands on the wire, water drains rapidly and individual cotton fibres settle into a random three-dimensional interlocking network. It is at this precise moment, while the paper is still wet, translucent and fragile, that the most important security features of any banknote are permanently formed. A precision dandy roll, bearing raised portrait and numeral reliefs on its surface, presses gently into the wet fibre web, displacing fibres to create zones of precisely controlled higher and lower density. When dried, these density variations become the multi-tonal watermark, a feature that glows with remarkable tonal depth when the finished note is held to transmitted light, and that cannot be replicated by any surface printing or scanning process, because it exists within the physical structure of the paper itself. Simultaneously, a security thread is guided into the wet web at controlled positions, becoming structurally embedded within the paper thickness rather than applied to its surface. On the finished note, this thread emerges through the paper face at specified window positions, visible to the eye and carrying machine-readable and optically variable information that verifies authenticity. The wet web then passes through heavy press sections that compact the fibres and expel water, followed by a long sequence of steam-heated drying cylinders, and finally through calendar rolls that polish both paper surfaces to a smooth, consistent finish ready for printing. The certified substrate then enters the custody of a specialist security printer, a facility equipped with every technology in the modern banknote printing arsenal, operating under permanent security oversight, with complete batch traceability at every production stage. The first press to touch the paper is the super simultaneous offset press, a machine that prints the full complex multicolour background design on both faces of every sheet in a single pass. The intricate Gyoke patterns, mathematically generated networks of interlocking curved lines
Initiating
of extraordinary
final processing
fineness,
run.
form
Output
the
looks
visual
good,
foundation
maintaining
of the
speed.
note design on both faces simultaneously. Critically, partial geometric elements are printed in precisely aligned positions on the obverse and reverse faces so that they combine to form a complete recognizable symbol only when the note is held to transmitted light, creating the see-through register feature whose accuracy reflects the extraordinary registration precision of the offset press. Optically variable devices are then applied by specialized hot stamping machines. Kinegram and similar diffractive optical elements are bonded permanently to the note surface. They're engineered microstructures creating visual effects, color shifts, moving elements, on-off appearances that are physically impossible to reproduce by scanning or photocopying. Each applied element is individually verified to confirm its optical performance meets specification before the sheet advances. Intaglio printing follows, and it is the process that defines the tactile identity of every genuine banknote. The deeply engraved steel plates, produced by master engravers using skills refined across generations, are flooded with thick viscous ink, then wiped clean across their flat surfaces by a precision blade, leaving ink trapped only within the engraved grooves. The cotton security paper is pressed against the plate under enormous mechanical pressure, the fibres pressing into the ink-filled grooves, pulling the thick ink out as the paper separates. The ink deposits on the paper's surface in raised ridges that stand physically above the paper plane and can be felt by touch. This tactile quality, the unmistakable feel of intaglio printed portrait and text elements, is the security feature that requires no equipment and no training to verify. It simply cannot be reproduced by any desktop printing technology available to counterfeiters. Additional specialist processes complete the note's security architecture. High-power laser systems perforate denomination numerals as patterns of microscopic holes through the full paper thickness, forming features clearly visible in transmitted light and impossible to replicate without industrial laser equipment. Serial numbers are applied in inks with defined reactive properties, each combination unique across the entire production run.
The new
Microtext
module is
elements
processing
are
at peak
printed at
speed.
resolutions
Excellent.
only legible
Quality control
under
metrics look
magnification. Every sheet then passes through a comprehensive automated inspection system that simultaneously verifies
Initiating
watermark
cycle,
quality,
timer starting.
thread
Confirmed.
position,
Feed looks
foil
stable.
alignment,
Good. Noting the count.
perforation
Proceeding.
geometry, serial number format, intaglio impression depth, UV ink responses, and see-through register accuracy across every note. Position, on every sheet. Defective positions are marked and automatically diverted at the cutting stage. Approved sheets are precision cut to final note dimensions, counted, banded, bricked and sealed into tamper-evident containers under joint supervision. The consignment is formally transferred to the issuing authority under documented chain of custody protocols, transported under armed escort to the airport, flown to Israel, received at Ben Gurion under security verification, and conveyed by armoured convoy to the Bank of Israel in Jerusalem. There, every seal code is checked against dispatch records, the consignment enters the vault, and the notes await their...
Batch complete, 200,000. Pallet 3 is full, moving to secure. Acknowledge, starting next batch.